Okay, there were a couple questions on the homework what was it, 2 nights ago, maybe 3 nights ago, this past week though, uh, that kids were asking about, and that was number 10. Remember this one here, number 10 on the homework a few nights ago, and then also number 11. Got lots of modulus going on and division by 10. Some pretty interesting arithmetic going on here. Let's see if we can work out these together. Okay, again, if I see this code, there's no way, if it's my first time seeing it, I know what's going to go on here in less than, I don't know, a minute, 30 seconds or so. It's going to take me a while to do it. I need to trace these variables and see what's going on. W starts off coming in at 491. Okay, so 491 is the first value of W. Then what happens? We set num equal to 0. Before the loop, num becomes 0. Now we're in the loop because 491 is bigger than 0, and we take num times equals 10. That looks bizarre. Why ever take 0 times anything? But that's what's going on here. And we take 0 times 10 to get 0 still. And then we take num plus equals W modulus 10. Okay? Num plus equals W modulus 10. A lot of steps, but each step here should be pretty easy for us. W is 491, modulus 10 gives us 1, and we add 1 to num, and we get 1. If I've already lost you, go back to the beginning and start again. You've got to get through this. This is on the AP exam almost every year, a question just like this. So here we are now at the end of the loop, and it says W divided by equals 10. So take W divided by 10, 491 divided by 10, and we get 49. Now back to the top of the loop. Is 49 bigger than 0? Yes, it is. So we go into the loop and take num times equal 10. Num was 1. Now it becomes 10. Next line, num plus equals W modulus 10. Num is 10 plus equals 49 modulus 10. 49 modulus 10 is 9. 10 plus 9 is 19. Then finally again, W divided by equal 10. 49 divided by 10 is just 4 using integer arithmetic. Go to the top of the loop. Is 4 bigger than 0? Yes, it is. 4 is bigger than 0. We go into the loop again. We take num times equal 10. So 19 times 10 is 190. Gets stored into num. And then num plus equals W modulus 10. 4 modulus 10. Well, 10 goes into 4 0 times. Remainder of 4. That's 4. Add it to num, 194. Look what you just did. We just reversed 491 into 194. And finally, W divided by equal 10. 4 divided by 10 is just 0. And 0 is not bigger than 0. We are done. So this is a reverse the number program, a reverse the number loop or method. Okay, number 11, let's see what happens here. Y is coming in as 1, 2, 3. Okay, num starts off at 0. If I use this pencil and paper over the right, or my table over the right, whatever you guys have available with you, just pencil and paper for you, I hope. Not doing it in your head. And you can do it, and not screw it up. But again, if I do it in my head, I'm going to screw it up a lot. And most kids will too. First time through, is 123 bigger than 10? Yes, it is. Go into the loop. Num times equals 10. Same as last time. 0 times 10 is 0. So it stays 0. Then num plus equals Y modulus 100. So 123 divided by 100 is 1, remainder 23. So 23 gets added to my 0. And now Y divided by equal 10 gives 12. Very similar to the last one. Back to the top of the loop. 12 is bigger than 10 this time. Is 12 bigger than 10, not 0? Yes, it is, just barely. So we take num times equals 10 and get 230. Num plus equals Y modulus 100. Okay, 12 divided by 100 is 0, but remainder of 12. So we add that 12 onto 230 and get 242. Y divided by equal 10 gives me a 1. Is 1 bigger than 10? No, we are done. 242. So that's number 10 and 11 off of the homework that looked like this. back on October 4th. Okay, so just a couple days ago we did these, and you put your answers in a Google form. Those were the two questions by far most asked about.